Okay, hello everyone. I just wanted to try and finish the question from class the other day, and then I have another one from AP Classroom. Okay, so find the area of the shaded region. This is all that we did together. Okay, talked a lot about that. We left off on this one, but we didn't necessarily finish it. I didn't write the rest of it down. I want to go through all the steps and the setup, and then I'll come back to the calculator for each of these. But we used our solver function to find theta is equal to 2.467. We were very careful that theta had to be between 0 and pi. Emma, you were asking the question, at 0 we got no sign change. At 2 pi we got an answer that was too big. So then we had to make our calculator look somewhere else. Excuse me, not 2 pi, that's pi. My less than sign looks like a 2. All right, then using the calculator, I found the derivative of y at theta is equal to 2.467. Found the derivative of x where theta is equal to 2.467, divided them, and then in the box is my final answer. Notice I didn't manipulate the derivative by hand. On a calculator problem, you do not have to, and you would just spend way more time than is required. All right, last part of the question we started in class. A particle moves along the curve so that d theta dt is equal to 2. Find the value of dr dt at theta is equal to 2 pi over 3 and interpret your answer in terms of the motion of the particle. Okay, so it's been a while since we used this, but this question asks us to derive our equation with respect to t. This is the variable r. This is the variable theta. We're looking to derive this function with respect to t. So what do we need in order to do that? We need our implicit differentiation step. So remember, when the variable in the equation and the variable you're deriving with respect to do not match, we need implicit. So what's the derivative of r with respect to t? Exactly that. What's the derivative of 1 minus 2 cosine theta? That would give me negative 2. Derivative of cosine is negative sine of theta. And then theta is not a t, so I have to multiply by d theta dt. So I'm looking for dr dt. Negative 2 times negative 1 gives me positive 2. Once I find the derivative, I can start plugging in the given information. Theta is equal to 2 pi over 3, and d theta dt is equal to 2. So 4 sine of 2 pi over 3. We can plug this in the calculator. It is a calculator problem, but this is also an exact value. 2 pi over 3 is in the second quadrant. Sine of pi over 3 is square root of 3 over 2. So I can leave it like that just because I said I was getting the calculator at the end. Interpret your answer. Okay, so since dr dt is positive, and I know that r is positive, then I'm moving away from the origin. The interpretation, this is worth a point. All right, so don't just, if you're not sure, our rate of change is positive, our radius is positive. So if we think about what those graphing would be, whatever our angle measure is, we're graphing in the positive direction. I'm moving away from the origin. But, all your work and then write some justification so that you don't lose that point. All right, new question from AP Central. Consider the polar curve defined by the given function. Theta is bounded between 0 and 3 pi over 2. The derivative function is given, and the figure shows the graph of r on that domain. So this is the graph of theta, cosine theta. Find the area of the region enclosed by the inner loop of the curve. Okay, so I always start by finding where my radius would be equal to 0. So that's at theta equal to 0. And that's where does the cosine equal 0 when theta is equal to pi over 2 or 3 pi over 2. All right, so I'm going to set up my table. And I'm looking just to graph that first inner loop. So I always start at 0. I come back to the pole at pi over 2. So I'm going to pick an angle in between there, pi over 3. I picked pi over 3 because the cosine of pi over 3 is a half. So when I plug 0 into my radius, I get a value of 0. When I plug in pi over 3, that gives me pi over 3 times the cosine of pi over 3, which is a half. So that gives me pi over 6. And then pi over 2 will bring me back to 0. Okay? So let's check out where that is on my graph. So I start at 0, 0. At pi over 3, which is a first quadrant angle, my radius is positive. So it'll put me, pi over 3 would be about there, closer to pi over 2. And then pi over 2 brings me back to 0. So here's my inner loop. Done. So remember, the benefit of the chart, the whole reason that I have you complete this is just so you can talk yourself into the direction. You can't just go from 0 to 3 pi over 2 for this area. We're looking for a very specific piece of it. So what's my area? 1/2 from 0 to pi over 2 of r theta squared. And I can even write it like that because we're going to plug that into the calculator. Okay? And just in case I run out of time, this is calculator active, and the answer is, oh, I hope I wrote it down in there. I think it's 0.127. Hold on. Make sure I wrote it down in the right spot. Yeah. Okay. Part B. For theta on our interval between 0 and 3 pi over 2, find the greatest distance from any point on the graph of R to the origin. Keyword. Greatest. What are we finding? We're finding a maximum value. So we're finding the maximum distance from R theta to the origin. How do we determine maxes and mins? We find where our derivative equals 0. Our derivative was given. Okay? dr d theta was given. So I'm going to find where dr d theta equals 0. Okay? So cosine theta minus theta sine theta, where does that equal 0? And I'm going to use my calculator. All right, I'm going to bring it up now. But remember, maximums occur. We can't forget about our endpoints. So 0 and 3 pi over 2 are musts. And we can even figure out what both of those are already, we know, equal to 0. So we're looking for our turning points within the graph. Okay, so I am looking, my modes in radians. I'm going to solve. So I have cosine of x minus x sine of x. Oops, didn't mean to do that. I'm going to tell my calculator to look at 0, alpha enter. So that gives me a value of 0.860. And Emma, this is the question you asked. You're like, how do I know? Will they tell me if there's more than one point of intersection? The answer to that is no. So I tested my leftmost endpoint. Now I'm going to tell the calculator to check around 3 pi over 2. And notice now I get a value of 3.426. And then let me just go back on my calculator here. 3 pi divided by, 3 pi divided by 2 is 4.7. So 3.426 is definitely within my interval. Okay. Now notice what I'm finding. I'm finding the maximum distance from a point r theta to the origin. So these values, using my calculator, I plug them back into r, right? And what's r equal to? R is equal to theta, theta times cosine of theta. So plugging those back in, I'm not going to take the time on the calculator to do that. You can verify you would get 0.561 and negative 3.288. So to answer the question, find the greatest distance, right? One sentence. The greatest distance from any point on R to the origin. And hopefully you know why it's this, even though it's negative. Right? A negative distance, when we're graphing, all that tells us is to go into the opposite quadrant. So the greatest distance from any point on the graph of R to the origin is 3.288. One sentence to sum up your answer. What did I do? I literally regurgitated the words of the question. Okay? All right, last part. There's a point on the curve at which the slope of the line tangent to the curve is 2 divided by 2 minus pi. At this point, dy d theta is equal to a half. Find dx d theta. Okay, we talked about this in class on Friday. Slope of the line tangent is always rectangular. That's always a rectangular representation. So dy dx is equal to this. Where does dy dx come from? Dy d theta divided by dx d theta. Okay, so I know dy d theta is equal to a half. So if I sort of set it up like a ratio, right, I'm looking for dx d theta. So I'm going to cross multiply. Divide both sides by 2. And now just putting that together. And I know that this is a calculator problem, but I would say leave it as its exact value. Okay, so you're allowed to use the calculator throughout the problem. And I do have, so the scoring options, 1 point for knowing dy dx is dy d theta divided by dx d theta. 1 point earned for the equation. And 1 point earned for the answer. So notice this answer is exact. So I would say keep that as such. And then you can pause and, look at where all the points are earned. Remember, every free response is worth 9 points. That's why it's really important that you're attempting each part, even if you can't do another part of the equation. Okay, so let's go back to this guy real quickly. I have a couple minutes left. Let me bring up the calculator. So when I find my derivative, so I'm going to derive, right? The calculator doesn't know what the variable is. So I'm going to derive with respect to x. First, I'll start with x. 1 minus 2 cosine of theta times cosine of theta. And I'm evaluating that at 2.467. Okay. Did not get the same answer. And I can see what I did. I'm moving a little bit too fast here. But check this out. So I opened a set of parentheses before the 1. I opened a set of parentheses before the x, and then I never closed it. So I'm going to insert a parenthesis. And there's my negative 2.576. So now I'm going to go through the same steps. I'm going to derive with respect to x. Now I have 1 minus 2 cosine of theta, close 2 sets of parentheses, times, and I don't even need that one, times sine of theta, and that parenthesis, at 2.467. I verify that I get negative 1.221. First time I did this, I'm not going to lie, I did dx divided by dy. But I can just use my up arrow. I'm going to take dy d theta, and I'm going to divide it by dx d theta. And there's my answer, 0.477. Okay, no need to show what the derivative is by hand. You can do it, but it's very time consuming. Okay, that's it for this video. Thanks, guys.